My name is Will Holman and I'm the Executive Director here at OpenWorks. And before I became Executive Director at OpenWorks, I was a frame and finish carpenter. I made cabinets, I built houses, I finished concrete for a lot of years. So today, I'm going to be walking through the safe use of our wood shop here at OpenWorks. It's broken into two sections, Wood 1 and Wood 2. I'm going to start off with a little overview of kind of how to get started. So the first topic we want to touch base on is PPE. Before you even walk in the shop, you're going to want to do a quick check of your person. Anything that is dangling or loose that could get caught in a piece of machinery, like a long ponytail, a bandana, or loose jewelry, needs to be removed or secured. When you check in and get your day pass at the front desk, you'll be issued a fresh pair of safety glasses. We disinfect these in a UV cabinet between uses, so each time you get one, it's going to be fresh and sterile. If you already wear glasses, we generally consider those acceptable. My glasses have plastic lenses, which are fairly shatterproof. If you have glass lensed glasses, we recommend that you wear these glasses over top. Second, hearing protection. We have disposable earplugs located right by the front door. We have taken all of our over-ear earmuffs away because of COVID, but you're welcome to bring your own from home. This is my pair. Masks are required right now because of COVID, but we generally recommend masks at any time in the wood shop. Even though we have built-in dust collection, air filters, and other steps in place to keep airborne dust to a minimum, there's always some stray dust in the air, and it can build up in your lungs if you're a woodworker for many years. Last are gloves. A lot of people associate gloves with woodworking if you're building a house or a deck or something. We generally ask people not to wear gloves in the wood shop. Even if they're fairly form-fitting like these, the extra fabric can get caught in the teeth of a saw blade and actually pull your hand into the saw as opposed to protecting you from the cut. This is the opposite of the guidance we provide in the metal shop. Just something to keep in mind. If you forget anything about this video we're about to go through, you can always look for our safety manuals. There's one in every shop. The wood shop safety manual is located on the door to the dust collector closet. And this goes over all the things that I'm about to go over with you today. So if you ever need a quick brush up, it's within easy reach. Next, we're going to talk a little bit about wood. In order to understand how to machine wood using all the tools that we have here, first you need to understand some things about wood. When a tree is growing out of the ground, it starts to put up bundles of cellulose fiber bound together by a substance called lignin. Over time, it develops a structure that's like a bundle of straws. These hollow tubes transport nutrients and water throughout the tree's structure. When you cut a tree down, the tree trunk is then milled into rectangular planks. But all those little straws that make up the wood fiber create the wood grain. So when you look at the end of a fresh cut piece of lumber, you can start to see the thinner bands are the cellulose and the wider bands are the lignin that binds them together. Now, just like when a tree is growing out of the ground, it is strong in a vertical orientation. You want all your straws going up and down if you're bearing weight. So when you're building a house, for instance, the stud goes up and down. When you put wood sideways and you have the bundle of straws like this, it's easy to bend, right? So that's something to keep in mind, both when you're designing your project, but it's also very important that you keep in mind the grain structure as it relates to all these different tools. Some tools can cut with the grain, some tools can cut across the grain, and some tools can do both. A cut with the grain is called a rip cut. A cut across the grain is called a cross cut. We'll talk a little bit more about that later. So now we're going to talk a little bit about types of wood. In general, there are two main types of wood: softwood and hardwood. While this rule is not ironclad, softwood generally comes from evergreen trees like pine or redwood or something like that. And hardwood comes from deciduous trees. This is oak, walnut, mahogany, cherry, and then this last example is poplar. Poplar is technically a hardwood, but it shares characteristics of both hardwood and softwood. Think of it as a big spectrum, and some things that are near the dividing line kind of act like both. As the name would imply, hardwood is denser, it's stronger, it grows slower as a tree, and it's much harder to machine when we take it over to the tools. Softwood is much less dense, it has a looser grain structure, it's very easy to shape, but also not as dense, so you can mark it with just your fingernail. As an example, if you look at the end grain of these two pieces next to one another, this is white pine and this is oak, you can see how much closer the little straws and the little growth rings are in the oak than in the white pine. Next we have manufactured and composite lumber. This is called MDF. It's essentially a compressed sawdust. It's very dense, it's very stable, it will stay flat. It's what we use as the spoil boards on the CNC machines. OSB is often used to sheathe houses. It's just made from chips and offcuts compressed under a lot of pressure and heat, and with some glue and binders added. This is particle board, which is probably the weakest and cheapest and least durable material here. It's just made of wood waste compressed with glue. And then this is plywood. If you look on the edge of plywood, you'll notice there are layers to it. Plywood is made by peeling a log and taking those long peels, which are called veneers, and gluing them together so the grain is oriented at 90 degrees to the previous layer. This makes a very strong and stable product that's perfect for making cabinets or something like that. Last, we have some materials that we don't allow in the wood shop. The primary candidate here is pressure-treated wood. You might recognize this as a piece of 4x4 like might hold up your deck or porch. The reason it has this greenish color to it is because it's treated with copper arsenate, which is a very toxic chemical that keeps it from rotting or being eaten by termites. But we don't want to be cutting in a closed environment where someone might breathe in the dust from it. We also prefer that you not cut composites or plastic materials. So this is a hunk of acrylic that I got from the laser lab. If you need your material cut down or resized to fit in the laser, please ask one of our techs if we can put a plastic blade on the table saw first. So that brings me to blades and how these pieces of material get machined. In general, you have big teeth that are spaced wide apart and small teeth that are spaced closely together. But your big teeth spaced wide apart are primarily for cutting soft wood or making rough cuts. Your fine-tooth saws are going to work better on tighter grained, denser material, and they're going to produce a finer cut. But also, the more teeth that you have, the more friction you generate when you're pushing a piece of material through the blade or pulling a blade through the material. That means, especially on hardwood, it's susceptible to burning along the edge, which makes an ugly mark that you have to sand off and can overheat the saw. So when we get over to the table saw, I'll walk you through some techniques to make sure that you're not pushing the equipment too hard. In the wood shop, every machine, the blade is turning towards you. So if you look at it from the side, well, it's a little more exaggerated with the big teeth. If you look at it from the side, the teeth are pointing this way, and the blade's gonna be rotating towards you. So as you cut a piece of material, the teeth are coming down into the material to do the work. If this blade was reversed, and the teeth are coming up through the material, it's going to grab the material and shoot it away from you. This general principle is very important to keep in mind with every machine in this space. The only machine where a blade will be facing away from you is in a handheld circular saw. All of the stationary bench tools, you are working against the blade. The table saw is the heart of the wood shop. We have two large cabinet saws here at OpenWorks. They're called cabinet saws because they sit on a big, heavy cabinet. This is important because you're going to be exerting a lot of force on this machine, and you want to make sure that it's heavily anchored to the ground. It has a cast iron table on top, an outfeed table, and a fence, which moves back and forth. The fence is how you set the width of the cut that you're attempting. There are two indicator bars on the fence. The one furthest to the right is the indicator that you're looking at. So right now it is set at about 6.5 inches. This tightens down with a simple cam. Once you feel it go tight, you don't need to keep cranking on it. It's as tight as it's gonna go. This will not move. You don't need to spend a lot of time jacking it down. If the table saw isn't already on when you come into the wood shop, turning it on is a multi-step process. You start by turning on the wall shutoff, and then you turn it on here. You will see these two lights blinking, red and green. The red will keep blinking until the saw has booted up. Once it is just solid green, you know the saw is ready to use. Now I said the saw booted up. That's because there's a small computer inside this saw. We use a special type of table saw called a SawStop. It is designed to save your hand from catastrophic cuts. There's two main dangers with a table saw: kickback and cutting your hand or arm. We'll address kickback in a minute. To prevent the cut to your hand, the SawStop runs a low voltage current through the blade. When that circuit is shorted out by moisture, i.e. blood, it shoots a solid aluminum blank into the blade with a blank .22 caliber cartridge. Simultaneously, the computer drops the saw arbor below the level of the table. This all happens in milliseconds. I'm not going to demonstrate it because this is very expensive, but if you go on YouTube to the SawStop page, you can see them testing it with a hot dog, and the hot dog is barely cut through the casing. So instead of having a catastrophic cut where you lost your fingers, you might end up with a nick so small you don't even have to go to the hospital. An important note about the SawStop technology is that it is prone to misfiring. It can be set off by any type of moisture. If your wood is wet, if the glue in your project is not dry yet, if there's conductive material in your project, like a nail or a screw or foil, all those materials are banned. You don't want to run anything wet or conductive through this saw. If you set off the SawStop that in a non-accidental way, in a way that was because you put the wrong material through, you're going to have to buy a new cartridge and a new blade, which will run you about 120 bucks total. Next, we're going to go over some of the adjustments on the saw. I already showed you how the fence worked, and there's two other main adjustments. The height, which is conveniently marked on the front of the machine. You can run the blade up pretty high but we do discourage using it all the way at its maximum because it puts a lot of stress on the machine and it's more likely to generate kickback. The second is the angle adjustment. So first loosen the dial in the middle, and then it can get gummed up if there's a little sawdust in the gears. You will see on the front of the machine, the angle of the blade is changing. If you want to be really precise, you can double check this with an angle finder, which you can find on the wall by the dust collector. This allows you to make beveled cuts or mitered cuts if you're running across the short grain. Now let's take a quick look at the blade. Behind the blade, we have what's called a riving knife. You'll notice it's the exact same width as the blade. As you push a piece of material through the saw, you're going to be opening up a thin gap in the wood. That gap is called the kerf. If the wood has a lot of tension in the grain or hasn't seasoned for very long, it may want to close up after the cut. This will cause the piece to bind and will kick it back at you. The reason is, as I mentioned earlier, with the blades rotating towards you, the front half of the blade is cutting into the material. But the back half of the blade, if the material closes around it, will catch on the material and throw it back at you. This is called kickback. This is one of the most dangerous things in the wood shop. Depending on the size of the piece of wood and the size of the motor in the saw, a piece can get kicked back hard enough to break a rib or even someone's pelvis. There are a couple ways to avoid kickback. First, have the riving knife in place. Second, you want the blade to only be as high as you need it to go. What that means is you want it to be just high enough that the full tooth will clear the material. This is called the tooth. That's the part that actually cuts the material. And this little piece is called the gullet. The gullet moves sawdust and chips away from the cut as the blade spins. So you want the gullet to be just above the height of the piece that you're attempting to cut. Once you've got the blade height settled in, tighten the dial in the middle of the height adjustment to lock the blade in place. The second thing you want to do to prevent kickback is make sure that the wide part of your cut is between the blade and the fence. So I'm making a cut here at 6.5 inches, and there's about a 2-inch strip that's left over. I could have also made this cut by moving the fence to 2 inches and leaving the 6.5-inch piece left over. The problem is now you're putting the majority of the weight and mass of the piece of wood on the outside of the blade instead of pushing against the fence. Even if you're pushing it through very carefully, there's going to be a natural physics are working against you, and you're likely to turn the piece. I'm exaggerating here, but even if you turn it slightly like this, again, those back teeth are going to catch on the back side of the board and shoot it back at you. Now the temptation when you're making, say you have a project where you have to make lots of 2-inch wide pieces, you don't want to have to keep readjusting the saw. Plus, you can build up inaccuracies if you're constantly adjusting the fence. So the temptation is to set to the narrow and run through a bunch of pieces. What we ask you to do is please rough saw. So if I have to make a bunch of 2-inch cuts, I'll maybe first cut this in half and then in quarters, and I'll end up with 4 pieces that are 2.5 inches long. Then set the saw to 2 inches and make your final set of cuts. It's a little more labor intensive, but at the end of the day, it's going to be more accurate and a heck of a lot safer. So our first 3 strategies for kickback to review, preventing kickback, are the riving knife, setting the wide part of the cut between the saw and the fence, and not having the blade be too high. The last is in body positioning. First off, you want to make sure nobody's standing behind you. If someone's using the jointer and you have a big cut that you're not sure about, just wait until they're done. Kickback could affect them. We've placed the table saws in such a way to try and avoid having machines behind them, but there's no way to 100% ensure that someone won't be behind you. And then the last thing is to position your body so you are not in the path of the board. People do this different ways. I personally like to stand on the outside of the blade. When you're pushing your material through the spinning blade, you're not actually pushing perfectly straight. You want to push straight with about 80% of your force, and you want to push into the fence with about 20% of your force. The other way that kickback can happen is if the material comes off the fence when you're in the middle of a cut. So you always want to make sure you're jamming the material smoothly and securely against the fence. That friction against the fence and the table is what's supporting the cut and keeping it stable the whole way through. If you want to check out more about kickback, just search table saw kickback on YouTube, and you will be rewarded with a whole bunch of terrifying videos about what kickback can do and further ways to prevent it. The last thing you need before you start cutting is a push stick. We keep push sticks, generally there's a small pile of them right here under the outfeed table. If this supply is out, because they get chewed up, we keep a back stock in the dust collector cabinet. Please just ask a tech for one. When you're pushing your material through the table saw, I'm right-handed, so these instructions are going to be for right-handed folks. If you are left-handed, it's still roughly the same. It shouldn't matter that much about your dominant hand. You're going to want to keep your left hand just as a loose guide that the material slides through, right? And then your right hand's in the driver's seat. So the right hand is the one that's applying the force both straight and into the fence. Once the back of the board is where your left hand is, you're going to want to take over with the push stick. Your left hand should never get closer than about here on the saw. We used to have markings on the saw, but they wear off from the friction. Your hand should never be inside the red area of the throat plate. So once you get the cut mostly through and you've transferred your motion to the push stick, just move your left hand out of the way. Most of the work's been done, and it should be fairly easy to complete the cut at that point. So with all those things said, we're about ready to make our first cut. Make sure the blast gate on the dust collection is open and that the dust collection is on. We've turned it off right now for sound clarity, but this will help suck the dust directly from point of generation. The last thing to demonstrate is the on-off switch for the blade itself. This is called a paddle switch. Many of the machines in the wood shop have a paddle switch because it's an additional safety feature. You have to pull it on so you can never accidentally bump into it and turn it on. And then it's got a lot of surface area. So as you come to the end of your cut and your hands are otherwise busy, you can just tap it with your knee. The last thing before you make the cut, with every machine in the wood shop, you want the blade fully spinning before it touches your material. If it's not up to speed yet, again, as it accelerates, as it's going slower, it's not going to cut through the material, it's going to catch it, and then as it accelerates, it's going to throw it. So you turn on the saw, let it come up to full speed, and then we're going to push it slowly and smoothly through the blade. When we get to about this point, we're going to transfer to using the push stick. Push the material all the way past the end of the blade. And once you've had a little practice, it helps to bump the offcut away from the spinning blade as you turn it off. This can sit here and kind of vibrate or even shoot back at you, although it won't be with nearly as much force as if the whole piece got pinched or bound up. Start with the sled clear of the blade. Now you have a safe crosscut on the table saw. If you want to learn more about the crosscut sled, you can ask one of our techs when you're in. That concludes the table saw section, and now we're going to move on to the compound miter saw. So the table saw was for making rip cuts in parallel with the grain. The compound miter saw is for making cross cuts across the grain. The table saw has a spinning blade mounted in a stationary machine that you push the workpiece through. The compound miter saw works the opposite way. The material stays stationary and you move the blade in and out of the material. The same principles are at work though. You'll notice the teeth are spinning towards you, which puts the force on your workpiece down and back into the security of the table and the fence. If the blade was mounted the other way, the piece would want to kick back at you. This is a great machine for making quick, repeatable cuts or for cutting compound angles. Now, what I mean by that is, first you can cut a simple miter. You can do that by adjusting the base of the saw. The base of the saw has a two-tier locking system. One is a cam, just like the fence on the table saw, and then there's a thumb lock as well. So you need to release the cam and press the thumb lock, and then you can rotate it to any angle that you want. You'll notice there's a red indicator that gives you the angle, and that all the common woodworking angles and multiples are marked on the base of the saw. The second adjustment, the reason it's called a compound miter saw, is you can actually cut two angles at once, which is really useful when you're doing crown molding or complex furniture, for instance. The second angle tilts the blade like so. It can go in either direction. Now there are little stops on the back of the saw that cause it to catch at 0. If you want to override these stops and do a more extreme cut, you can flip them up out of the way. These little black plastic wings on the back of the saw, they're a little hard to see, and that will allow the blade to pivot further than normal. When you're making an extreme angled cut, you need to make sure that you're not going to cut into the fence. For instance, if I lay the saw all the way over to a 45-degree angle, it's hitting the aluminum fence where it is now. To adjust the fence, you come on the back side of the saw. There's a little black plastic wing nut, and this slides. This angle is roughly the extent of the saw blade's ability to pivot, so you just want to make sure that this clears. Test it dry before committing to your cut, or you'll do a lot of damage to the saw and a lot of damage to yourself. So you're going to want to make a dry run or two, make sure you're clearing the saw fence, and then tighten it down. If you're just making a straight cut, which is the majority of what people are doing the majority of the time, you're going to want this fence pushed in fairly close to the blade to support your material as best as possible. The blade has a pivoting guard here. This is spring-loaded and it's attached to the arm action of the saw. So as you pull the blade down, it's slowly revealing more of the spinning teeth. This is to protect you from any incidental bumps or cuts, but you want to make sure your body position is such that your hands are free and clear of the blade, and again, you have no loose clothing or jewelry or hair that can get caught in it. The last specialty adjustment is a stop system. So if you want to make a lot of repeatable cuts of a certain depth, if you want to make a lot of repeatable cuts that maybe don't go all the way through the material, you can flip this black lever down and undo this screw to your desired depth. Swing nut is a little poorly positioned, but you can back this nut out and then it will hit this little plastic lever and stop the blade at a predetermined depth. That's for making certain type of joints if you're building a cabinet or a piece of furniture. And the last feature of this saw you'll notice is that it's a sliding saw. Most miter saws just go up and down, which means that the piece of material you can work is limited by the diameter of the blade. You can't cut anything bigger than the blade. This allows you to cut much wider pieces of material because you can start all the way out here and push the blade through the material. In a way, it sort of acts like a mini table saw when you're activating the sliding function. If the sliding function is throwing you off and you want to limit it, there's another stop on this side of the machine. This little lever flips forward and hooks onto here and keeps it from sliding. We generally ask people not to engage that, but if you're feeling a little shaky on the saw and the sliding is throwing you off, you can lock that. So the procedure for making a crosscut is fairly simple. Just like on the table saw, you want to secure your piece of material against the fence. That means you're going to want to push back and down. Generally, you want to keep your hands outside of the metal frame of the saw for maximum safety. The only time you might want to creep a little closer in is if you're cutting a smaller piece. Now, we ask that you not cut pieces shorter than the bed of the saw. Getting close to the blade, it's both a danger to your fingers, but it's also more liable to kick the piece back at you. Once you have your piece set up on your mark, line it up dry to make sure you're accurate. Then there's a trigger that starts the saw. It's a two-part trigger. There's a little safety here that you have to depress first, and then the main trigger. And you're going to want to draw the saw smoothly and slowly through your material. And when you reach the bottom of the cut, release the trigger, but hold the blade down until it stops spinning, and then withdraw it from the material. If you withdraw the blade from the material while it's still spinning, you may kick your offcut across the room and hit somebody. Now, in some cases, you're going to be dealing with a piece of wood that is not perfectly flat. We provide shims to the left of the saw to shim up your workpiece so that it is stable. If you have a piece that is slightly warped, maybe a rough piece of material you're trying to cut down before you take it to the planer or the joiner, and it's, say, off the table at the front but contacting at the back, when the teeth start to interact with the workpiece, it's going to jerk it out of your hand. It can also bind the blade and kick the saw violently back up at you. So you want to make sure that your material cannot move and that it is shimmed securely. If it's cupped, you want the cup down in a rainbow position as opposed to a smile position. And that is the compound miter saw. After you've cut your material down and cleaned it up a little bit, you might want to put some holes in it for various reasons, either for fasteners, for hinges, maybe to pass cords through, depends on your project. The drill press behind me will allow you to make fast, repeatably accurate holes. But first we need to learn a little bit about drill bits. A drill bit that most of you are familiar with is called a twist bit. It's the same as you might see in the metal shop. On the leading edge of these flutes is sharpened, and as it goes in, it cuts. It's called a twist bit because it's sharpened on the twist of the bit. To make bigger holes, twist bits only go up to about a 1/2 inch typically. Sometimes there's bigger ones, but in woodworking, it usually taps out at a 1/2 inch. To make bigger holes, you have two options. You have Forstner bits, which look like a cup, or you have what's called a paddle or a spade bit. So the paddle bit has a sharp tip so you can center your hole, and then it has two cutting tips. And you notice they're twisted to one another to work with the rotation of the machine. So this is what's actually doing the work of the cut as it scrapes away the wood. Now, a Forstner bit also has a centering punch, so you can center your hole where it needs to be, but then it has a whole bunch of cutting teeth around the perimeter. A Forstner bit is generally going to be a lot more accurate for a couple of reasons. One, even a small Forstner bit is a lot heavier than a paddle bit. It also generally has a shorter shank. When these bits are mounted in the machine, the length of the shank means that there's more play by the time you get all the way down to the tip. The shorter the shank, generally a little more accurate your hole is going to be. Second, the weight gives it more mass and momentum as it's spinning, so it stays more stable in the machine. It's not going to do what we call chatter, which is wobble slightly off of axis. And then last, instead of just 2 cutting teeth, it has 8 cutting teeth, which means it, just like finer teeth on the saw blade for the table saw or the compound miter saw, you're going to get a finer quality of cut. This is important because the drill bit is the one machine where you're cutting across the grain both ways. When you're making a cut on the table saw, you're going with the grain. When you're making a cut on the compound miter saw, you're going across the grain. When you're drilling a hole in it, you're simultaneously cutting with and across the grain. This can lead to some really shredded up and gnarly looking holes if you have a dull bit or you're not using a machine like a drill press that holds everything in perfect position. Trying to make holes with these big bits with a handheld drill is a recipe for disaster. The drill's going to want to walk around on you. It's hard to get it to go straight up and down. and it's hard to secure the piece all at the same time with just 2 hands. The drill press works just like your basic hand drill, except it's mounted on this handy stand, which you can clamp your material to, and then you can control the depth and the speed of the cut very easily so that it can be a highly repeatable and accurate hole. Attached to the drill press is metal bed is a little sacrificial wooden bed. This is to prevent blowout on the back of your material. As the drill bit exits the back side of the material, it's going to want to peel up the wood fibers, and it'll make a very messy hole on the back side of your cut. The way to prevent that is to support it against a sacrificial surface that you can over drill your hole slightly into. In general, if you're using a bigger piece, you want to make sure that you secure it with clamps. Smaller, lighter pieces that are thin and not putting a lot of pressure on the machine, you can secure with just your hand as long as it's clearly out of the way. This is a really good way to hurt yourself, however. Especially longer pieces will pivot when caught by the drill bit and can kick back at you or really torque your hand or wrist. So we do recommend that you clamp your material at all times. Now, getting a good clamp can be a little tricky because the bottom of the bed of the drill press has all these different castings on it, so it can be hard to find kind of a flat surface to clamp to. What you can do in that case is get a second piece to help secure your material. So we're going to take a longer piece that the clamps can reach all the way to the edge, and we're going to clamp it down this way. Once that feels nice and secure, you're going to want to do a couple test drives to make sure that your bit is lined up with where you want your hole to be. If the bit in the machine is not the one that you want, you're going to take the chuck key. It's attached to the machine with a little piece of surgical tubing so we don't lose it. Use that to loosen up the chuck. Take the bit out. Put it back in. Just hand tighten. And what I'm checking for here, the way the chuck works is there are 3 little jaws in here. You can get the drill bit misaligned so that only 2 of the jaws are grabbing, and then the bit will spin a little off axis, right? So you want to make sure that it's evenly seated on all 3 jaws of the chuck. Once you hand tighten it as tight as it'll go, use the chuck to give it another crank or 2 and make sure it's in there. This on-off switch is also a 2-parter. The green switch has this little ridged bit of plastic at the top, which you have to pull up. Sometimes it gets a little jammed up with dust. And then press down, and that turns it on. And then same as the table saw, it's a big paddle switch off. Now you're just going to want to rotate slowly down, let the machine do the work. Don't yank down on this handle and push too hard. You're going to put too much stress on the bits. So the last I should mention is that you can adjust the depth. So this has been set to only go this far. It's hitting the stop. So to adjust the depth, just loosen up this handle. Now it's loosened and I can take this as far down as I want to. But if you want to make a hole that's to a very precise depth, you just line up the mark with where you want your depth to be and tighten the handle, and it won't go past that spot. So slowly roll it down into the cut, let the machine do the work. With Forstner bits, you need to withdraw the bit from the material periodically to clear chips. Otherwise, the bit will bind up in the hole and it'll start to burn and stop spinning. Make your cut all the way through. Bring it back up to the rest position. You have a good clean hole. You'll notice that even with back support, there's a little blowout on the back side of the cut. To prevent that, put a second sheet of sacrificial material. The reason that it blew out is because this has been beat up a little bit, so it actually wasn't as supported as it should have been. You can just put something down from the scrap bin to make sure that the back side of your material is protected from blowout. And that is the drill press.